Okay. All right. I think we finished homework 1 just about on time last week. And then we were supposed to start homework 2. But before we do that, any questions from anyone? From anything we covered or Anika, all okay? Okay. Sumer, Arnav, Rahil, I don't see you. Please turn on your videos soon. We'll get started meanwhile. Dipra, you're okay, right?
Yeah.
No doubts and all. Okay. Did you guys have time to try homework 2 as well as homework 3?
Yeah.
Siddharth, did you?
So I finished homework 2, homework 3 just half.
Okay. All right. Rahil, how about you?
So I've done homework 2, homework 3 I tried, but I couldn't solve many of them.
That's fine. So let's see how far we progress today. So first one, I sent out the answer key also. So just in case you guys did not get the right answer, you could have attempted it once more and checked. But anyway, we'll go through the full solution now. So first one, you will see my screen, right? All of you? Yeah. Okay. PQR has A and B as given. So essentially, all the information has been captured in the diagram here. So it's just listing out what's already given. Determine the values for A and B. Okay. So sine TUS is 4 by 5. TUS is 4 by. This is the only thing that's not in the picture, right? So everything else is given. So sine of this angle, sine of angle U, I'll just say equal to 4 by 5. Okay. So let's just apply this. Works well with cosine rule here, right? So A square plus B square minus 2AB cos 60 equal to 21 square.
So
Okay,
we
so
can actually do the sine rule also. It'll be
we can
easier.
use for this one, is it?
Yeah,
Okay.
because you can
So,
do 4 by 5 upon A is equal to sine 30 upon B. So we'll
but
get the relationship between A and B.
but we don't know about sine of this one, no? In the PQR triangle, I don't have any other angle, no?
No, so then you can put one as theta and one as 120 minus theta because the total is 180. And then you can again use sine rule over there. And then after you do it, you
Okay,
get the
so
answer.
maybe that's all. That also works out. So I thought given two sides A and B and then given an angle, cosine rule was straightforward. Either way. So if that works out, that's great. The other one, I don't have an option. Sine of this thing is given. So this is the second one. A upon sine of this opposite angle equal to B upon sine of this opposite angle. Right? So this one, straight away you get a relationship between A and B. So how much is this? 5A equal to 8B, is it? 8B. 5A equal to 8B. Okay. So now I can just apply that here, right? 5A equal to 8B. So let me just multiply throughout by, let's say, 64. Okay. The reason I'm doing that is so that I have everything in terms of A square. So 64A square plus 64B square would be what? Square of this, right? 25A square. I don't want to deal with fractions. So 64B square, which will be 25A square, minus 64 A into B. B is 5A by 8. Right? 5A by 8. So which is 8 here. Equal to 21 square into 64. I'll just leave it as this. I'll just put a line here. Okay. Now, okay, let's simplify 89A square. Why is this? 89A square. Sorry, actually there's more, right? Minus 40A square here. So which is 49A square. So 49A square equal to 21 square into 64, which is 8 square. So I can write A as square root of the whole thing. I don't need to multiply at all anything. So 21 into 8 by 7. Am I right? Or am I doing some mistake? 21 and sorry?
It's right.
It's right, right? Okay, so which is 24. So A is 24. Okay, all right. This seems reasonable, reasonably drawn to scale, right? So 21, 24 seems fine. And then B would be whatever, 5/8 of that, right? 5 by 8 into 24, which is 15. So 24 and 15. Okay. Now, Siddharth, what were you saying? In this first triangle also you used sine rule, is it?
Yeah, I said that is possible because
Okay.
you can do
Okay, tell me, walk me through it, how that works out better.
That doesn't work out better. I was just giving like, I think this is easier, but I was giving another alternative because we can put like a PRQ as theta,
Okay, all
and we
right.
can
So
put
let's say,
R
okay, let's say this is theta, as you say, and this is 120 minus theta.
minus theta.
So you'll still have 21 upon sine 60 equal
Yes.
to A upon whatever sine theta equal to B
Hmm.
upon sine of 120 minus theta.
I
But
think it
120
becomes more
minus theta,
complicated.
yeah, exactly. You have to expand that again,
Yeah.
more or less.
The
At best, it might be working out to similar complexity as this.
yes.
Okay, but
Yeah.
anyway, it's good to explore multiple options. So good, you tried that. So that was straightforward. Question 1. Question, just paste question 2. All okay, right? Everyone okay on question 1, right? Sumer, you're okay on question 1?
Yes.
You've got the same answer. Okay, all right. So determine the number of quadruples of positive integers A, B, C, D in an increasing sequence he has given, and then satisfying both of these equations. So the moment I see this, it's very obvious that it's just a factorization, right? So it's A times C plus D here, and then plus B times C plus D here. So effectively, this is A plus B times C plus D. So product of two integers giving 2023. The first obvious step would be to factorize 2023. And given we are in the year 2023, we should all know the prime factorization of 2023. If not, let's do it once. So it's divisible by 7. So 7, because I've done it in the past, I know it's divisible by 7. 7 2s are 14, 7 8s are 56, 7 9s are. So 17 square. So always be prepared for prime factorization of that particular year, or maybe the following year. So 2024 is also a good one. We know it's 2025 minus 1. So it's 45 square. 2025, we should recognize it's 45 square. Therefore, this is 44 into 46, which can be broken down further, right? 11 into 2 into 2 into 2 into 23. So just know the prime factorization of the years around now. Aage piche thoda. Okay, so right now it's 7 into 17 into 17. So we have product of two quantities, A plus B into C plus D, giving a product of 7 into 17 into 17, which is 2023. But the sum of these four quantities is 296. Okay, so if we distribute, for example, if I put a 7 into 17 here and a 17 here, or maybe whatever, 7 into 1 here. Okay, all right. So if I do something like this, then I get only a small number, right? 7 into 17 as A plus B means A and B should individually be less than 7 into 17, which is, what is it, 119, right? So there's no way that A plus B plus C plus D will add up to a big number like 296. So the only possible way is one of them is 289. Okay, so let's say this works out to be 289, and then this works out to be 7. I'm saying this because A and B are the smaller ones, C and D are the bigger ones. So, and then 289 plus 7 is 296. So A plus B plus C plus D will give the 296. Okay, now we have to distribute A and B, but then A should be less than B, right? So let's say we have to distribute 7. So the only few possibilities, right? So A and B, let's say I make two columns A and B. Then it's either 1 and 6, or 2 and 5, or 3 and 4. Okay, so A and B is that combination. If I look at C and D separately without the constraint that B has to be less than C, then this can again go from 1 to 88, 2 to 87, all the way till whatever, 144, 145 will be when almost equal, right? But the problem is C should be bigger than B. So C should be bigger than B, right? Therefore, we can start off with a narrower range. So let's say, let's deal with this one first. Suppose B is 6. So B is 6 means automatically C has to start with 7. And then the balance is 282. And then this can go 8, 9, all the way till 144 and 145. Okay, so this collection will correspond to B being 6. Okay, so let's not count how many just yet. Let's write out. And then similarly, if I have this collection, 5 ke liye, then this will start slightly earlier, right? So 6 to 83, all the way till 144, 145. And the last collection ke liye, so you have to start or rather you can start even earlier, right? So C can start at 5, right? B is 4, and therefore C can start at 5 to 84 all the way till 140. You don't have to write all of this so elaborately. I'm just explaining it. Okay. So in this sequence, we have a few. In this sequence, we have a few. In this sequence, we have a few. So it's clear that the number of terms is increasing by 1, right? So we can take the middle one and multiply by 3, right? So let's say this is n. This is n plus 1. This is n plus 2 terms. So when I sum, it's going to be the middle one times 3. So it's the beach wala times 3, right? So how many are there from 6 to 144? From 6 to 144 is 144 minus 6 divided by, sorry, there's no common, the common difference is 1, right? Plus 1. So it's 139. So what I was doing here is, for example, suppose it's 6, 8, 10, all the way till 144. How do you quickly determine the number of terms? It's 144, the extremes, divided by the common difference, plus 1. So that comes from simple arithmetic progression. So in this case, it's not divide by 2, it's divide by 1. So it's consecutive numbers, right? So it's just plain 138 plus 1, which is 139. So it's 139 in the beach wala. So it must be what about 138 or 113, 140. So it's 139 into 3. So which gives your 420 minus 3, which is 417. I think that was the answer, right? I'd given the answer key earlier. Can someone confirm? 417, Tana? Sumer, do you have the answer key?
Yes,
Yes, yes.
417. Okay, cool. Question 2.
so can A be 0?
It says positive integers, no, easily.
Oh, okay.
Okay, but yes, if it said whole numbers, then obviously you would have accounted that. So always pay attention to all of these edge cases. I'm just thinking, what other variant of this? Suppose they had given one other simple variant, key A less than B and C less than D. They didn't give B is less than C. Then these two parts are independent. A and B ke liye we have 3 categories, and then C and D ke liye we'll have all the way from 1 to 88, 2, 3, so on. So C can go all the way to 144. So 144 for this category. So in that case, we'll have more flexibility, right? So 3 into 144. Suppose they didn't give B is less than C wala constraint, then it just becomes 3 times 144. Another constraint could be, I don't know, in this case, probably does not matter. They could have given A less than or equal to B, less than or equal to C, less than or equal to D. So depending on that, you have to adapt, right? So less than or equal to will not make a difference for A and B because adds up to an odd number. Here also adds up to odd number. But shayad, here it will make a difference. If B is 6, then C can start off with 6 itself in that case. So pay attention to every single detail: strict inequality, integers, positive, non-negative. Suddenly they'll say non-negative. Non-negative means 0 is included. All of us know, but in the heat of the moment, we tend to forget, right? Or overlook rather. Okay, makes sense? Ritisha, all good? Okay, nice. Question 3.
So these problem sets that you send, are all the questions going to be tough like this, or are they going to be easy ones as well?
No, obviously the first few questions in any paper will be very easy. You can say these are in the difficulty level of questions 15 to 20, that range, right?
Okay.
So I'm assuming like 1 to 14 type of levels would be fairly okay-ish for you guys to do. Beyond 21 will be quite hard. So I wouldn't say not venture. It's if you guys can do that, that's excellent. But the range of difficulty I've picked up in the range 15 to 20, not just from AMC, I've picked up a few from Canadian Olympiads, a few from Asian Olympiads as well, in that range. So this is where you guys need help. But 1 to 14 ke liye, you guys are all mostly sorted, unless you do silly mistakes, which I don't want you to do. Beyond 21, whatever we are able to get on that particular day, if there's a spark, you're able to solve 1 or 2, that's great. But let's make sure the 15 to 20 is where, with some extra help, you guys are able to conquer that. Okay. So long story short, the range of difficulty of these questions is around 15 to 20 K aspas. Okay. Question 3. Suppose ABC is a right angle. Oh, sorry. Slightly smaller. ABC is right angle triangle. AB is given n into n plus 1. integer sides, right? N is a positive integer. Determine the number of positive integers n less than 100,000 for the length of BC is also an integer. Okay, so right angled at B. So AB, sorry, AC is the hypotenuse, right? So AC is your AB square plus your BC square. Okay, so this is what? N plus 1 into n plus 4 whole square. And then minus AB is n plus 1 into n ka whole square. So we need this to be a perfect square, right? So which means BC is, I can take n plus 1 common outside, so no problem. That's not going to have a problem. N plus 4 whole square minus n square, so much n square will get cancelled. 8n plus 16, right? So this guy, so this is BC, right? So if BC has to be an integer, 8n plus 16 must be a perfect square. इसको और भी थोड़ा simplify कर सकता हूं मैं. I can take 4 common outside. So this is 2. So I can just focus on 2n plus 4. So ultimately the problem reduces to 2n plus 4 should be a perfect square. Right? 2n plus 4 should be a perfect square. And n is less than 100,000, right? So n can start with 1. So for example, n can be 1, 2, and all. Sorry. 2n plus 4 should be a perfect square, right? Yeah. So well, what is the first one? If n equal to 2n plus 4 should be a perfect square. Correct. Okay. All right. So which is the maximum? So starting from n equal to 1. N equal to 1 is how much? 6, right? So 6 to 200,004. Okay. We are searching for perfect squares in the range 600,004. Okay. Yeah, or rather even perfect squares, right? Even perfect squares in the range 6 to, because 2n plus 4 will be an even number. So we are searching for even perfect squares from 6 to 2004. So let's start with the first one would be how much? Would be 4 square, correct? So 4 square, 6 square, 8 square, all the way till. So the only thing that we don't know right now is the end point. So that we can figure out fairly easily, right? So we can start cutting off in two digits. Let's focus on 200004. So we know that 20 is 4.5 square, right? We just saw 445 square was 2025. So again, we have to approach this without calculator. With calculator, koi bhi kar lega. That's not a problem. So without calculator, how can we be intelligent in solving this, right? So we know that 450 square will be 2025 followed by 00. Correct? Now, we don't have to evaluate 449 square and all that precisely, right? So we know that 449 plus 1 whole square will be 450 square, right? So the difference will be roughly on the range of 2AB. So 2 into 450 ke aspas. So in other words, the 449 square will be roughly around, say 1000 come, right? So 449 square will be around 201500, right? 1000 come. So 448 square will be maybe 900 come, but chalega. We don't have to be super precise. 200500, or maybe I'll just make it more precise, right? So 900 to itna hoga, and this will become 200700. Okay, but we can clearly see that 448 square exceeds 2000 substantially. Iske baad, anyway, we are looking at only even square, right? So 448 say we'll go to 446 square, which will be roughly around 2000 come, yes, say, right? Am I doing the subtraction correctly, guys? 2000, 1000, 3000. So 2000 come yahan se kitna milega? 198-ish, right? Whatever, it'll be safe. So 446 is safe. 448 is also safe as in it's outside. So we just have to count the count of even numbers from 4 to 446. So how do we do this? Difference 446 minus 4 divided by common difference is 2 plus 1. So how much is this? 442 divided by 2 plus 1, which is 221 plus 1, which is 222. It could be off by 1 or 2. Let me also open the answer key.
Yes, sir.
222 was the correct answer?
Yes, sir.
Yeah, 222, right? But yeah, you have to be, I mean, here knowing the answer, we can go a little reckless, but Obviously, you don't know the answer, and if there's choices, choices will be fairly close. If there's an answer which is 221, 222, 223, then you have to focus a little bit more. If the answers are spread apart by 5 or 10, then it can be a bit bindas, right?
So
It
can
can
you
be.
scroll up for a second?
Sorry, say that again.
Can you just scroll up for a second?
Oh, sure.
Just to this. Yeah, yeah. Just one second.
You want me to
Okay.
repeat some part from where, or you okay?
No, so it's fine. It's fine.
Okay, so again, you guys understood. My key takeaway is how to find perfect squares, or approximately find square root of something. I think that was the only key takeaway. Rest of it you guys would have figured, right? So it's just counting number of perfect squares. That's it, without doing elaborate calculation. Okay, so that was question 3. All okay? Any doubts, guys? Arav, you're okay?
Yeah.
Okay, Manan, I don't see you. Please turn on the video as feasible.
So it's on, but yeah, I'm okay.
I'm able to see everyone else except you. Okay.
So wait, I'm reading.
Okay, Arnab, you're okay?
Yeah.
Okay, question 4. Question 4. Sorry, guys, I'm just struggling with pasting it here. Okay, so triangle of area 770 is divided into these portions, 11 regions, equal height, 10 lines. Okay, starting from the top, every other region is shaded. What is the total area? Okay, so we can clearly see we have a bunch of similar triangles. So let's say, okay, let's say this is the topmost is 1 square. I know this exact numerical value is given, but let's say this topmost one is 1, then this one would be 2 square, which is 4, right? So this will be 4, and then this one will be 9, correct? So this will be 9. So in proportion, the areas would be 1, 4, 9, 16, and so on, all the way till the last one is how much? Is it 121? 1, 2, yeah, 11 of them, right? So 121. So in proportion, so I'll say a square into. So the areas of the successive regions, the areas of successive triangles, not regions, is a square into 1, a square into 4, a square into 9, all the way till a square into 121. So this 121 a square is the entire thing, right? That is given to be 770. Okay. Now we want, what about the areas of the differences? So it'll be a square into 1. The next one would be 4 minus 1. The next one would be 9 minus 4. The next one would be 16 minus 9. Aisa, right? And the last one would be 121 minus 100, which is 21. So we want to add up all the shaded areas, which will be a square into the alternate ones here, right? 1 plus 5 plus 9 plus 13 plus 17 plus 21. Let's ek bar gin lete hain. Do we have the exact same count? We have 6 here. And yeah, we have 1, 2, 3, sorry, 4, 5, 6 here, 6 shaded regions. So this is what we want in proportion. That's it, right? So rather than doing again the sum, we can just do this beach wala and times 3, or the extremes and times 3. All of this is just arithmetic progression ka application, right? Rather than waste time adding all of them, I'll just go with the center and multiply by 3 because there are 3 of them. So 22 times 3 is 66. So 66 out of 121 as a fraction of 770. So 11 goes 6 times, 11 goes 11 times, 11 goes 7 times. So 420.
Sir,
Okay.
there's a faster way to do this.
Yeah, go ahead, please.
So you can imagine like completing this parallelogram, which would have like areas into 2. And then,
Excellent.
then you just find the shaded area.
Okay, complete the parallelogram. That'll be 770 into 2. And then
You have 6 over 11 of 770 into 2, which would give you, like, if you complete the parallelogram, all the stripes, and then you divide that by 2. So that's just 6 over 11 into 7.
6 over 11.
Yeah,
Okay. Wonderful. Okay, nice.
Even I did that 6 upon 11 into 770.
Excellent. Very good, guys. So for people who may not have followed, I'm just so they're basically extending this ISA, and then they are putting this ISA, and then they are essentially saying I'll complete this shaded region. They'll complete this shaded region. Correct? Is that what you guys mean?
Yes.
Yes.
Perfect. Sorry, Sumer, did you have another doubt? I saw your hand was going up, beach mein. Something else. Did you raise your hand, Sumer, or no? Okay.
No.
Okay, that was question 4. Question 5, logarithm. Determine the values for x for which. Yeah, this is an interesting one, right? So I made a silly mistake while solving this, and it's good, right? So very illustrative of one of the main concepts that we have seen, right? So obviously we'll start off with log x to the base 2 as some variable, let's say y or something. So this is square root of y times log x plus log 4, right? So it's y plus 2 plus 1 plus square root of y times log of x minus log of 64. So 64 is 6. Sorry, 6 to the base 2, right? So 6. And then plus 9 equal to 4. Okay, so this is y square plus 2y plus 1. So it is, we would immediately write it as y plus 1. Okay, and let's go with that, and that's where the mistake lies. Okay, so and then it's immediately tempting to see this is y square plus minus 6y plus 9, right? So y square minus 6y plus 9, which is y minus 3 whole square. So it's tempting to write y minus 3 for this equal to 4. But if we do that, what do we get? We get 2y equal to how much? 6, is it? 1 minus 3 minus 2, 6. So y equal to 3. Okay. So while y equal to 3 would be one of the answers, it does not give us the full picture. So Keshav, do you see? In fact, I highlighted there's a problem in this step. Can you tell me what the problem might have been from this step to this step?
Yeah, not completely sure.
Okay. Rahil, are you able to spot your mistake?
Yeah, so
Spot the mistake?
square root of x square is absolute value of x. So not just x.
Exactly, right? So what if y plus 1 is negative, right? So the square root of that would be negative of y plus 1. Similarly, what if y minus 3 is negative? Square root of that would be negative of y minus 3. Okay, so yeah, so exactly as Rahil answered, square root of something a square is not a, right? Square root of a square is instead mod a. So depending on a itself is positive or negative, it could differ. So how do we modify our working? So till here is okay. So now, so for first approximation, why am I not able to delete this? Okay. So for first approximation, we know it's square root of, no, not approximation. We know it's square root of y plus 1 whole square. And we also know it's square root of y minus 3 whole square. So till here is fine. Now, the critical points are minus 1 and 3, right? So let's draw a simple number line. And let's mark 2 points. Take minus 1 and take 3. Okay. And let's split the number line into 3 parts. Okay. So in the left part, when y is less than minus 1, less than or equal to does not matter, edge case does not matter, then which means what? Y plus 1 will be a negative number. So square root of y plus 1 will be negative of y plus 1. So this will become, the equation will become negative of y plus 1, because just imagine y is minus 1.3, right? So negative of minus 0.3 will become a positive number, right? That's what we're seeking. And if y plus 1 itself is negative, then y minus 3 will also be negative. So same applies to this also. So this becomes minus of y minus 3 equal to 4. So in this region, we are solving effectively this equation, which is minus 2y. How much is this? Minus 1 plus 3, which is how much? Plus 2 equal to 4 minus 2, which is 2. So we get y equal to minus 1. So in this range, y equal to minus 1 is the only solution. So this part is fine. Okay. Now in the Beachwala interval, exact same thing. Minus 1 to 3, y plus 1 becomes positive number because it is because it's positive, right? Y is greater than -1. So in this case, y plus 1 is fine, but y minus 3 is negative. Therefore, square root of y minus 3 whole square is negative of y minus 3. So the equation that we are trying to solve is this. So which is nothing but the equation we are trying to solve is 4 equal to 4. So the question we should ask ourselves is, for what value of y is 4 equal to 4? For all values of y, 4 equal to 4, right? On the other hand, suppose the equation was equal to 5. Then again, we'll ask the same question. For what value of y will 4 be equal to 5? The answer would be for no value of y, 4 will be equal to 5. So the answer will be everything or nothing in such cases, right? So all values here are all included here. Okay, and similarly, so all of them are included. And then at 3 or 3 or beyond, both become positive. So the equation just becomes y plus 1 minus y minus 3 equal to 4, which is 2, which is what we initially got. We got 2y equal to, how much was this? 6, and y equal to 3. So the edge cases are also covered. Everything inside this is also covered. So final result is -1, 2, 3, but that's y. We are interested in x, which is 2 power that, right? So 2 power y is x. So 2 power from here, 2 power y is my x. So 2 power -1 all the way till 2 power 3. So half to 8, the entire range. Which is why in the answer key also I had given that square bracket half to 8. Okay. I'm just curious, how many of you guys made the silly mistake and got just 8? Okay, Ritisha is admitting. Okay, yeah, I made this mistake also. So thankfully, when I saw the answer key, I realized I was doing something wrong. Okay, good. Question 6. Computer program is programmed to choose an integer between 1 and 99 inclusive, so that the probability that selects an integer equal to log of, okay, blah, blah, blah. So let's check if the probabilities add up to 1. Hopefully they should, but you should do a simple sanity check. That way, if your understanding of the question is wrong, then you'll find something, right? So the probabilities will be log of 100, 1 plus half, you're adding up everything, right? So you can just multiply times 1 plus 1 by 1, right? The first one is 1 plus 1 by 1, 1 plus 1 by 2, all the way till 1 plus 1 by 99. So when we do this, what do we get? Hopefully we should get 1. So let's check that. So this is 2 by 1, this is 3 by 2, this is 4 by 3, all the way to 100 by 99. So we can see the telescopic cancellation. So everything will cancel except the 100 and 1, 100 and a 1, right? So log of 100, which is 1. So we have checked that the sum of the probabilities adds up to 1. That's good. Now, the probability that 81 to 99, both inclusive, would be what? So log of, it'll start from 82 by 81, all the way till 100 by 99. So kya bachega? 82 will get cancelled, 83 will get cancelled, 99 will get cancelled, 100 and 81 will remain. So it'll become log of 100 by 81 to the base 100. Okay, now this quantity equals 2 times the probability that x equal to n. So 2 times log of 1 plus 1 by n, which is n plus 1 by n. Okay, and you can clearly see 181 are perfect squares. I can write this as 10 by 9 whole square, right? So it becomes 2 times log of 10 by 9. So just by pattern recognition, we can see that n plus 1 is 10, n is 9, and that's it. So n is 9. Fairly easy question. Although it looks maybe a bit daunting when you look at it, but easy question only. Okay, question 6. I'm just thinking any other interesting questions could be made from this. Okay, not really, but one thing comes to mind. You guys should know this basic approximation. It might come in handy sometimes. I don't know, for AMC it might. So log of 1 plus x is, we have this expansion, right? X minus x square by 2 plus x cube by 3 minus x power 4 by 4 all the way till infinity, right? So this is the Taylor series expansion for log of 1 plus x. Just like you have expansion for sine x and cos x. So maybe we should just quickly recap those. Let me just quickly do that now. But this is very important. And this helps in a couple of places. Oh, by the way, this is to the base e. This is log to the base e, or rather I should write it as ln of 1 plus x. Okay, so ln of 2, which you would have studied in radioactivity and all in chemistry, right? Half-life, log 2 to the base e is a very prevalent thing, which will be 0.693, right? ln 2 to the base e, log 2 to the base 2.71 will be around 0.7, right? 0.693. That comes from the expansion, this expansion, right? So 1 minus 1 by 2, there's no factorial, just remember, and so on. So if you just do it by hand calculator, you will see this approaches 0.693. And while we are at it, you should know the expansion for sin x and cos x as well, right? Sin x is x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, odd factorials. And cos is even, starting from
1 minus x square upon 2.
factorial, correct, plus x power 4 by 4 factorial, and so on. So this could come in handy sometimes. And then e power x, you guys know, it's 1 plus x square by 2 factorial plus x cubed by 3 factorial, and so on. All these are important. ln, sin, cos, e power x. Okay, and interestingly, if I do ln of 1 minus x ke jagah mein minus x. So this will be minus x. X square will anyway be minus x ka whole square. So it'll just be, every term will be positive in that case. Every term will be negative in this case. In which case you can just write it as minus of x plus x cubed by 3 plus x power 4 by 4 and so on. Okay, so this is how actually continuous compounding also works. Okay, fine. Let's not go there. Fine. Okay, so I thought this is a good aside. You should know. Question 6 that was. Question 7, parabola. So you have the parabola and the line intersecting. And the area of VBC is given to be 72 by 5. Okay, so let's find the intersection points. So ax square plus 2 is intersecting minus x plus 4a. So let's write it as a quadratic in x. So the 2 minus 4a just becomes 2 minus 4a just becomes, what was I saying? The c term, the constant term, equal to 0. Okay, so x is minus b plus or minus square root of b square minus 4ac. So 1 plus 1 minus 4ac, right? 1 minus 4 into a into 2 minus 4a. Okay, so whole upon 2a. So it's minus 1 plus or minus. This is, I think, a perfect square, right? 16a square minus 8a plus 1. So it's 4a minus 1 whole square. So it's 4a minus 1 whole upon 2a. So the two roots are, if I do minus 1 plus 4a minus 1 by 2a, it becomes 4a minus 2 by 2a. The other root becomes minus 4a by 2a, which is minus 2. Okay, so clearly this b is the minus 2. It's negative, right? So this is minus 2 comma something, and this is 4a minus 2 upon 2a. So 4a minus 2 better be a positive number, right? The way he is drawn, a is given to be greater than half. So 4a minus 2 is positive. So this is, I'll write it as 2a minus 1 by 2a. So this is 2a minus 1 by 2a, comma, blah, blah, blah. I don't care what the y coordinate is. Now I just have to find this area, right?
No,
So I
that's
want-
a minus 1.
Sorry, say that again.
2a minus 1 by a.
Oh, 2a minus 1 by a. Yeah, right. Good. 2a minus 1 by a. Thank you. So this is 2a minus 1 by a. Okay, and now I want to find this triangle, right? So b to v to c. Okay, so I can split as multiple ways to do this. I think it's easy to just keep this height, right? So the base is same. If I split into two triangles, right? The left wala triangle and the right wala triangle. So the base will anyway be let me mark this point as D or something. Base will anyway be VD. And we know VD is, for both the triangles, the base will be VD. So V is how much? V is the vertex, right? The vertex is at x equal to 0 in this case. So V is 0, 2. So V is 0, 2. And D is the y-intercept of the line, which is 0, 4a. Okay, so VD, that gap is 4a minus 2. Okay, so the area of the two triangles, when you add up, I get half into the base, which is common, which is 4a minus 2. And effectively, I have to add up the two heights, this height and this height. Or rather, this height and this height, right? Which is essentially the x coordinate in positive terms. The first one, x coordinate is minus 2, but effectively I'm looking at it as a height, which is 2. And the other one is 2a minus 1 by a. Okay, so this quantity is your 72 by 5. So barring any silly mistake, I think this should work, right? So this is 2a minus 1. So 2a minus 1 times 2 times 2 is 4a minus 1 upon a equal to 72 by 5. So let's multiply 8a square minus, if I do some silly mistake, please catch me, guys, minus 6a plus 1 whole times 5 equal to 72a. So which is 40a square minus 30a minus 102a. Minus 30a minus 72a, which is minus 102a, plus 5 equal to 0. So yeah, so 40 times 5 is 200. You can easily guess it's 102, right? So 40a square minus 100a minus 2a plus 5 equal to 0. So I can take 20a common outside. Sorry for the scribbly, but you guys are following, I'm sure. Minus 1 times 2a minus 5. Right, so which is 20a minus 1 times 2a minus 5, I think. Therefore, a should be 20a minus 1 would give a equal to 1 by 20, but somewhere he says a is bigger than half. Therefore, a has to be the other one. A is equal to 5 by 2. 5 by 2 was the answer, right?
Yes.
5 by 2. Yeah, question 7, 5 by 2. Okay, so not a difficult problem, but thoda cluttery, right? So you just have to maneuver without making mistakes. That's it. Otherwise, conceptually, it's a very easy question only. Okay, question 7. Question 8. Question 8. Determine all the real numbers in this case, right? So no integers. So it could be 0, negative, whatever, such that all of these three equations are met. Log of x plus b plus c. So let's start, right? So log of, the way I try to write out is, because it's difficult to take focus from x and y every single time. So I'll just first write out all the x valas. Log of a, if there are multiple equations, this is what I would recommend you also do. So finish writing all the x's and then come to all the y's. So 5 plus b plus c, log of 11 plus b plus c, and equal to 5, 4, and 3. Very convenient, spread by just 1. So I can just solve. There are 3 equations, 3 variables. You just have to intelligently solve. That's all. If I do the difference between these two, I get 1 equals, I get eliminated. C is already eliminated. Log of the reciprocal, no, the ratio of these two, right? 3 plus b by 5 plus b. Similarly, if I do the difference between these two, I get 1 equals log of 5 plus b by 11 plus b. Okay. So in other words, both of these quantities, 3 plus b by 5 plus b is also a power 1. 5 plus b by 7 power b is also a plus 1. I might as well write this as a, and this is also a. So this is also a, this is also a. So which means I can just say, I can ignore the a and I can just cross multiply and find my b. So 5 plus b whole square equal to 3 plus b times 11 plus b. Okay, so b square will get cancelled anyway. So 25 plus 10b will remain here. Here 3b plus 33 plus 3b plus 11b will remain, which is 14b. So we can solve it. 4b equal to minus 8, b equal to minus 2. I can plug that in one of them. So b equal to minus 2, matlab a is 1 by 3. So a is 1 by 3, b is minus 2, and then c is whatever, right? Easiest way to put it is here. So that because this log 1 becomes 0, so c is just 5. So you have your answers, right? 1 by 3, minus 2, and 5. Okay, again, not difficult, but just have to spend a little bit of time and just solve it without mistakes. That's it. So there'll be questions like this also, right? So where it's fairly straightforward, you just have to give time, and give time matlab do it efficiently, not give time as in take 20 minutes. Okay, question. Okay, let me park question 9 for just a second. Let's do question. I'll come back to question 9 at the end. Question 10, square lattice. Okay, square lattice. Determine the area of ABCD. Again, multiple ways to do it. I'm curious to listen how others might have done, but let me just go through what I thought was easy. So I just drew a coordinate system. You can draw the coordinates anywhere, right? I'll call this as the origin. I'll count everything from this. So everything is in the 4th quadrant. So some people might keep the bottom left as the origin. That's also fine. So essentially, if I find coordinates of D and A, I'm good. I'm sorted, right? So let's quickly write out the equations. So let me label these lines as L, M, N, and P or something, right? So I'll find the intersection of L and P. But you can write out the equations very quickly, right? You don't have to write very elaborately. So you can see the slope is 3 for the line L. So the line L, so line L ke liye, we know the slope is 3, and though we know the y-intercept is minus 3. Because it's 0, minus 3 here. So y is 3x minus 3. Let's write out for P and N as well. So line P, you can see the slope is negative and a shallow slope. So minus 1/3. So y is minus 1/3 x. And then it passes through origin itself. Therefore, there's no y coordinate at all for it. So we found L, we found P, and then let's find equation for M so that you can find points D and point A. So M will also have the same slope of 3x, but it intersects at 2, right? At 2, it should be 0. Therefore, 3x minus 6, right? And just to repeat, so at x equal to 2, it passes through the x-axis, right? Therefore, x equal to 2, the y value should be 0. So 3x minus 6. Now it's just a question of solving these two and solving these two. Okay, so L and P ka intersection will give me D. So D would be the intersection of these two. So I can say 3x plus 1/3 x. So 10x by 3 equal to 3. Therefore, x is 9 by 10. And more or less, it makes sense. If this is 1, this looks like x coordinate of 9/10. It's not unreasonable at least. So 9/10. And therefore, the y coordinate is minus 3/10. 1 minus 1/3 into x. So D ka mil gaya. Similarly, we'll do for A. So if I equate these two, again, 10 by 3x will be equal to 6. So literally it's double. You can see that it's proportion, right? Therefore, x is 18 by 10 and y is minus 6 by 10. Okay. So we just want, we want AD square. The square of the area of the square is just AD square, which is just by distance formula. It's just 9 by 10 square plus 3 by 10 square. The difference between these two, right? 9 by 10 square, which is easy, right? How much is this? 81 plus 9. So 9 by 10 becomes the area. Okay. Any other methods? Keshav, did you do another method?
Did the same way as well.
Same. Okay. How about you, Ritisha?
Same.
Same. Okay.
I did similarity.
Okay. Please explain.
Yeah, so it's actually like we'll have to label points if I'm to explain like this, but like you already know some of the lengths because they're like one apart, and
Yeah.
then And then, yeah, and then there's one application of Pythagoras theorem, which would give the length of, which would give the square of one of the sides, which is AB, which is also the area of the square. It's
Sorry.
like, like this.
Oh, hard to explain without drawing it, is it? Okay.
Read the square if you
Oh,
make, you
okay.
can add a lot
Okay.
of.
I will draw these for you. I'm curious to listen, like what are the method, right? I'll draw the lattice for you. Maybe it'll come in handy in some other case. So let's learn. Okay, so I'll draw the vertical also. Okay, go ahead, Anika.
Yes, so
Should I label all of these points?
yeah, probably.
Huh?
Yeah, I think you should label the
Okay. Have you labeled them in a certain way, or shall
No.
I just randomly go?
I've not labeled them, I've just done it like without label.
All right, E, F, G, H, I, J. I'll just keep going. Okay, continue, please.
Yes, so you can call ADX and then like one of the sides of the square X, and then similarly DE will also be X because EF is equal to FG. So by similarity of triangle EDF and EAG.
Mhm.
And then you can do similarity for so there is one point which you haven't labeled, but if you look at GB and then the intersection of GS and PI, which is
I have labeled all the points now, I think. Which one?
the black and orange. Can I?
Yeah, please annotate, or you can tell me approximately coordinate 2, -3, something like that. You can tell me. Okay, that point. Okay, I see.
And
Okay.
then, yeah, and then you find that this is like if you use this as 1, and this should be 2/3. So this you get 2/3, and then this is also 1. This entire thing.
Mhm.
And then you'll find that if you do similarity here, it should be 1/3, this smaller portion.
Okay.
And then you can, and then since this is a right angle, you have wait, this.
Okay, fine. It's okay. Okay, I understand. A bunch of similar triangles, and then getting the proportions, you solved it. Okay, understood. Yeah, makes sense. Thanks, Anika. Actually, I'm not able to delete other people's annotations. Can you delete yours, please? And the problem is it remains in the same place as I scroll down also. Yeah, I have to figure out. Maybe I should delete it from Zoom. Okay, cool. Question 11. Question 11. Determine the length of AB. So cos of ACD is given as -3/5. Okay. And then what else is given? BC is given to be 2. This is given to be 1. AC by AD is given to be 3/4. So let's say this is 3x and this is 4x. Okay. And then I have to find AB. Let me call this as Y. So I have to find Y. Okay. So, and then since cos of this angle is given, obviously it's a cosine rule wala application. So let's write. So 3x squared plus 1 square minus 3x whole square, right? So 9x square. So 9x square plus 1 minus 4x wala whole square whole upon 2AB. So 2 into 3x equal to cos of that angle, which is -3/5. Okay, so this is one equation. In fact, let's everything is in x, right? We can just solve this quickly, right? How much is this? So this is -7x square plus 1. So when I multiply, I get -35x square plus 5 equal to -18x. Okay, let me get everything to one side. 35x square minus 18x plus 5, sorry, minus 5 equal to 0. Minus 5 equal to 0. So I can solve for my x as minus b plus or minus square root of b square minus 4ac. So 20 into 35, which is 700. 700 plus 33, 24 is 1024, which is assuring me that we are in the right direction, perfect square, right? So it's 18 plus or minus 32 whole upon 70. So positive root be 50 by 70, so 5 by 7. So x is 5 by 7. We can take that x and put it for the left-hand side, wala. So y square would be 2 square plus 3x whole square. 15x, sorry, 3x is 15 by 7 whole square, right? 15 by 7 whole square. Minus 2 into 2 into 3x into cos of this angle. Cos of this angle will be positive 3 by 5, right? Cos of theta and cos of 180 minus theta are negatives of each other, right? You guys know this. So into 3 by 5. I think that's it, right? Then we should be able to solve and get y. So let's see whether this results in a proper answer. So y square, 3x whole square plus this square minus 2 into 15 by 7 into 3 by 5. Okay, all right. So 4 plus 225 by 49 minus, how much does this simplify to? This is 9, 36 by 7. Okay, so hopefully this will give a perfect answer. Let's see. So 196 here plus 225 here minus 36 times 7, 252, right? 20, 42, yeah, 252 whole upon 49. So how much is this? 225 minus 252 is minus 27. So minus 27 is 169, okay, which is assuring. Therefore, y is 13 by 7. 13 by 7. I think the answer scheme has it in fraction. 1.857 should be that, right? Close to 2. Yeah. Okay. So by the way, you guys should know this 1 by 7 wala logic, right? So 1 by 7 is 0.142857. And everything after that will be cyclically from here. So 2 by 7 will start from 2. So it'll be the same 285714. 3 by 7 will start with, you can roughly see 1428, next should be 42, right? So it'll start with 4. So it'll be 42, the same will get recycled. 428571. And similarly, 4 by 7 would be starting from 57. And then 5 by 7 will start from 70. So 7 and then cyclically from here, 701428. 6 by 7 will be 0.85714. Okay, so it's a very nice property for the divide by 7 series. The digits gets recycled. Okay, again, question 12. Hollow cylinder. So this is just a simple displacement wala problem, right? Hollow cylinder has a radius of 10 and a height of 100, and it's filled till a depth of h. So you have something like this. You have a long, okay, it's filled till depth of h. Okay, so this is h. And now you're dipping a rod, and then the length goes up, right? So this becomes like this. The height goes up. So you have this rod, which is thin, right? So I'll just draw a very thin rod here. Obviously, the height has gone up. So the height has gone up to here now. So, and this height, this new height is 64. This height is given to be 64. And this is the h height that we have to find. So the volumes are same. So it's just pi into 10 square, radius is 10 into h, should be pi into here. if you look at the cross section of it, is from the top, it'll be like this, right? There'll be a small hole here with the red, which cannot contain water. So the water is all here. So it's pi into 10 square minus 2.5 square into 64. Okay, so obviously we don't have to do 10 square, 2.5 square and all that. It's just a scale factor, right? So 10 is 4 times 2.5. So I can just say 4 square times h equal to 4 square minus 1 square times 64. The ratio is 1:4 from 2.5 to 10. That's all matters. So 16h equal to 15 into 64. So h is 15 into 64 by 16. So which is 60. Okay, sounds good. And then I think there's only one problem left, right? So I'm out of time. We can discuss this. I wanted to tell one thing on the question 9. Question 9 was it, or is this a problem that we skipped?
Yeah, 9.
Question 9. Yeah, so essentially you see a pattern here, right? Let me just paste it. So 1/3 is just, so this will be 0. So the terms will add up to 0 plus 0. And then for 3/3, 4/3, and 5/3 will be 1, 1, 1. At 6/3, it will go to 2. 6/3, 7/3, and 8/3 will be 2, 2, 2, 3, 3, 3, and so on. Right? So depending on where we terminate, the polynomial will have. So first, let's not worry about P of m with the floor function. Let's just try to find how the function will behave when the number of terms is a perfect multiple of 3. So we can take three cases, right? So if m is a perfect multiple of 3, then how many terms we have? If m is 3k plus 1, and if m is 3k plus 2, right? So for each of these cases, we'll know, right, how many perfect triplets we'll have. And then the balance, depending on whether it's 3k or 3k plus 1 or 3k plus 2, you will have some balance, right? So this will be a function of k. This will be also another function of k, right? And then once you get these expressions in terms of 3k, 3k plus 1, and 3k plus 2, we can figure out how to commonly put them as a floor function of some P of m. Okay, we'll discuss this at the beginning of the next class. But in case you guys did not make much headway with this, at least try to get expressions for when m is 3k, when m is 3k plus 1, m is 3k plus 2, without worrying about the floor function. Just get an expression, and then we'll go from there. We'll finish it up. Okay, and then we'll discuss homework 3, and I'll assign one more. Okay, let's meet next week. Chalo, bye.